This is the second session of ADDTEX Back-to-School Masterclass. In the first session, you have received information about the project in general, as well as what is the MOOCs and the courses that the project offered in general. For today's session, we focus on a smart solution in the textile industry, and the topic called the smart path. Myself, Mohammad Nias Morshid. I am a researcher at the University of Borås in Sweden, and I'll be moderating today's session for the next 1 hour. So our masterclass today will follow this outline. So Martha already introduced and give us a warm welcome. And I will take a short time to introduce the smart path or smart transition MOOCs that we have developed in ADDTEX project. Followed by that, we have our partners Sensingtex, VUV, CeNTI, and SCILIF, SCILIF. SCILIF, they will present their part. And at the end of this masterclass, you'll be able to ask questions. And like Martha mentioned, raise your hand to ask question, and your microphone will be unmuted. So moving forward with the MOOCs, again, you have received this brief information about the MOOCs that we have developed in this project. It divided into smart, digital, and green transition, and each of them has 5 unit of learning outcomes, 5 lessons of each courses, and each 5 courses were divided for 3 different tracks of people that can receive it. So why we divide them into 3 different groups is because the need of 3 different groups are different, and that has been achieved through a need analysis. You can go the detail about how we choose these topics from the session 1 of the masterclass. So today's session will focus on the smart transition out of the 3 transitions that we have studied and developed courses in this project. For smart transition, the short learning courses that we have developed in this project will cover the terms and definition of the smart transition in textile industries and their evolution in time and technologies. The aim is to provide specific courses to upskill the target groups that we have divided into 3 target groups with knowledge and resources related to fundamental processes and materials development in the domain of smart textiles. And these courses that you have seen, the 5 courses that 5 modules in the learning outcomes for each of these tracks, they are divided into smart textiles introduction and challenges, innovation linked to smart textiles, innovation linked to functional textiles, resource efficient textile technologies for smart and functional textiles, and finally integration of technologies to develop composites and electronic textiles. So if you take this MOOCs, take these courses, you will be able to grasp this content from the module that you have developed. And the learning path for each tracks, technicians and graduate, engineers and professionals, managers and mentors are different depending on their need. For example, the technicians will be gather more information about the fundamental processes, where engineers will be about to get more about advanced functional applications and challenges. The managers and a mentor will be focusing mostly on innovative processes with the scope of the implementation of these smart transitions and follow up with the 2030 Agenda for Sustainable Development. To take this course, to understand the course, and also to get the most of this out of this course, we expect that the learner or the students have some basic knowledge about the textile fibers and processes in general, and the basic techniques for textile preparation, so weaving, knitting, and so on. So that will help you to understand the content in this course. And additional knowledge about e-learning environment will also benefit you since these all courses will be given online. I'll not go detail in this, but you will have this slide in recorded, so you can read it also. That is each of the paths that we have decided for technicians and graduates, managers and mentors, engineers and professionals. Their learning units, which is the 5 of each of them, has different main topics and objectives. And these topics was to help you to gather and to be more relevant on your need based on your job description and what is your end goal in Frank. So you all these courses that you have, all these topics that you have was tailored for each of this learning path. So how we can get this course? You can go to our website at ADDTEX.eu and choose the courses that is suitable for you. This is an example for the courses, how it looks like in the website for a smart transition for engineers and professionals. If you are technicians, you can also choose another tab to access the courses for technicians and graduates, and also same for managers and mentors in general. So why we take the smart path and why we actually focuses on the smart transition is because of this urgent need that we have on a smart manufacturing and smart products in general. And if you take these courses, you'll be able to grasp a brief overview on this context. And they bring endless opportunities in our textile sectors, starting from the technological advancement, sustainability, consumer demand for innovation, competitive advantage, and global challenges. So thank you so much.
First of all, thank you very much for inviting us, inviting Sensingtex to give you a little bit of information about what we are doing around the area of smart textiles. So if that's helpful for you, I will be happy at the end of my talk. So basically, I'm going to talk about the topic of my talk is going to be about how really electronic textiles can deliver add value by trying to collect data where other electronics can do. That's where we can really find applications of electronic textiles as a really a key enable of new advantageous solutions within this field. Okay, so I'm gonna talk about three different areas and give you a little bit of figures about our journey in this area for quite a long time. So first of all, I'm gonna give you a few figures about our company, short introduction. Then I'm gonna talk about the smart textiles, textile technology we have built so far during the last 15 years, and our main applications and solutions we are building out of it. Okay, so basically we're considering, because this is indeed when you consider smart textiles, we are considered a deep tech company, also digital, because the company is not only focused on electronic textiles, basically based on stretchable electronics, but also we did a move on software. So we are considered a software company, and then lately we have developed quite a lot of algorithms based on from the raw data generated by our own devices. So we are using AI for different purposes. Okay, and this is where we are also considered digital, not only hardware company but also software company. So our journey. So as I told you before, so we have been in the smart textiles market as a company. This is our focus more than 15 years, 15 years. So and then it took quite a long time to develop our electronic textile technology. Around 8 years, thanks to private equity, but also grants and the investment of the company, the profitability we reinvested it over the last decade. So and then finally in 2018, there is like a big let's say a big or a huge process to develop all of this technology. And then in 2018 is when we could reach 1 million euros in sales of hardware components based on smart textiles. So from there, we noticed in the market that there was a lack of supply chain in the smart textiles industry. So there was a lack of, let's say, product generation based on our own technology. And then this is the reason because why we decided to move forward on developing our software department and software solutions. So, and then the last part of the last 3 years, so we launched our own software solutions and then end products. And we also expanded our capabilities in other continents, like in North America. Okay, so if we have to talk about the different packages of the technology, we can divide them into 6 different, let's say, packages. So the first one is the large area stretchable circuit. So if you want to make truly smart textiles, you have to consider to develop your own, let's say, printed circuit boards like traditional electronics. So we need to have let's say a completely wired solution, very flexible in terms of layouts. And then you can choose different approaches based on textiles like knitted, electronics, woven. We at that time we chose the way to use screen printing. One very well-known technique to print let's say drawings or in the textile industry. So we have rebuilt that technique into a complete, accurate solution to print circuits on top of textiles. Okay, and then we developed this solution. I'm going to talk just give you a little bit of figures, and then based on that, we either can fully print a device, which means that from the circuit, from the conductive traces, so we can print different materials that will enable us to make sensors or actuators, and we also developed that part, okay, which is also part of the supply chain within the electronic industry. Then we later on developed IoT sensors based on our smart textiles. We developed different IoT sensors with all the capabilities that the market is using in that sense, IoT sensors, like with APIs, with all of the tools that you can enable other developers, mainly software developers, to develop things like that. And then we moved to software, and then we developed data analytics to process this raw data we generate through our devices, and even artificial intelligence, another way to make algorithms. And even we develop our cloud edge and cloud platform, which is native or it can be also agnostic. I'm going to talk a little bit more, but not very much during this talk, because I'm going to be much more focused on the electronic textiles. Okay, so if you are willing to do something like that, so it's just a recommendations to be a part of different organizations, in not only from textiles but also in electronics, in computer science, IT. So you have to some kind of a mix of different disciplines. So these are the kind of customers we have. Mainly, we work mainly in healthcare. So the main applications of smart textiles, as you may know, healthcare, mobility, military. So these are the main sectors where there is quite a lot of investment in there. So, and then we are working with big players and some other we during quite a lot of time we work with different startups and scale-ups ecosystems, and then that was the initial steps, because the supply chains didn't exist at all. And then you have right now big players having quite a lot of interest on smart textiles. Okay, so this is another approach to group the different technologies we have developed. But basically, the technology we have developed is something we can manufacture sheet to sheet or roll to roll. So we manufacture with a screen printed equipment. When it becomes sheet to sheet, it's large area. So consider a equipment of 2 by 3 meters. Okay, this is very big in terms of screen printing. When we talk about sheet to sheet, and when we talk roll to roll, is around 0.5 meters wide. Okay, So we can print different devices fully printed, and basically the production has been approved. All of our approach has been approved through. We go through the DNSH new approach from the EU sustainability principle. So and it is considered technology 5.0. Okay, so we have two different versions of the technology. And the approach is basically to try to make something which is enough flexible, not for sure equivalent to traditional PCBs within the electronic industry, but these are kind of a few figures about what you need to consider to do when it is about electronic textile circuits. Okay, so we can print on textile or on TPU. You may know about thermal polyurethane. It's like a membrane, like a textile membrane, but thermally stabilized, because when you print electronics, so mechanical stability and specifically dimensionally speaking, so it should be way beyond compared to the traditional stability, dimensional stability in textiles. So we print on different backings, different thicknesses, from 80 to 120 microns. We can print, either we print direct printing with AG, or we can even print with copper. In fact, it's not copper, it's a transition of copper. So and then we can build devices which are up to 100% elongated, and then we keep the electronic features. So we can print very thin conductive traces and be enough robust. And then we can make multi-layer, double side, through holes, footprints when it is a matter to bring SMD components. So the technology is very flexible in that sense to be capable of making different devices. So we have quite a lot of expertise on pressure sensing. When you talk about making electronic textiles, the beauty of making electronic textiles is that they are large area. And instead of making, tiny sensors, so you can make like sensor element based displays, like the analogy of picture element, and then you can make different devices based on that. And how to apply them, you can make either lamination, stitching, in mold, injection. We have different simple technologies in textiles to be capable of attaching these electronic devices onto textile substrates. And then based on that, we built complete IoT solution sensors. Basically, we moved to home to solutions that not wearables. We prefer to start with textiles, like for bedding applications, for sitting and for flooring applications, and then we built a complete platform based on the hardware and the software, and also AI on top. This is what I wanted to share with you, that it's not enough with the smart textiles. You need to build a complete solutions. And then I don't want to extend my presentation. So basically, you can find on our website different applications in healthcare for pressure injury, for prevention. We can count people, we can monitor people in car seats. So these are the different solutions we have provided right now. So thank you very much for your attention. So and any questions you may have, I'm going to be available later on. Thank you.
Yes, thank you very much. Thank you for a chance to be a part of this masterclass. Hello, everybody. Good afternoon. I am at VUB responsible for international contacts, as already mentioned. Our company is located in the town of Ústí nad Orlicí. We are in northeastern part of the Czech Republic. So now let me share with you our story of our journey from cotton to smart textiles. It began more than 75 years ago in 1949, when our company VUB was founded as a Cotton Industry Research Institute. We were a center of textile engineering and technology research and development, concentrated at open and rotor spinning technology. A significant transformation occurred in 1992, where From State Research Institute, we became a private joint stock company, and our activities gradually changed and developed. Our current portfolio is really broad. However, still it is based on and continues our history. The most important and profitable is the special machinery engineering and production of precision machine parts. We also specialize in customized design, construction, and production of unique single-purpose machines and devices, which are tailored to specific needs of our clients. We have not abandoned research and development activities. We continue to focus on innovations in both textile machinery and textile technologies. And thanks to this, we can remain at the forefront of industrial progress. We aim to utilize the results of this research and development work with the goal to bring our research discoveries to the markets and make our innovation useful and accessible to customers. So we manufacture and supply a wide range of specialized textile products of high quality and advanced functionality. Frankly speaking, just research and development activities and projects allowed us to move from cotton and rotor spinning to smart textiles. We are actively involved in projects that explore the application of new materials in textile technologies in close collaboration with industrial partners and also academic institutions, including universities and other research institutions. Our journey to smart textiles began with development of protective and functional clothing based on functionalized fibers, providing products permanent functional properties. Our first project and development works we dedicated to flame retardant underwear, especially for firefighters, ESD protection. They represent working clothes for electrotechnical industry, wearable skincare, textile products, and our last product line is ADDTEX, which covers light-emitting clothes, so-called glow-in-the-dark. To smart textiles, let us especially cooperation with colleagues of West Bohemia University in Plzeň. Together, we solved the project combining textile and electronics on the topic to realize smart textiles with integrated electronic for patients' health monitoring. We started the work on bed sheets that would detect moisture and presence of a person. We initially thought this would not be so much demanding. However, we immediately faced a challenge, finding a suitable conductive material for the sensors. We tested various commercially available options like individual wires, Litz wires, metallized fibers, metallized yarns, but none met our electrical conductivity requirements. So there was no chance but to try to find our own solution. And thanks to this, I can hereby present you our solution, electrically conductive hybrid threads, branded as HighCont. In practice, these threads are based on ultrafine metallic wires in a wire diameter at about 30 microns. They are combined with synthetic filaments, especially high tenacity polyester, by a two-step ring twisting process. This product can show excellent electrical properties, especially low linear electrical resistance in ohm per square meter, which is required by smart textile applications. Our product is fully compatible with standard textile manufacturing processes like weaving, knitting. Moreover, they are suitable for sewing on standard sewing machines and special embroidery machines. So our threads are able to be used for completely functional conductive tracks, circuits, fixed rods, or heating elements. Moreover, they show high mechanical resistance, and also resistance to maintenance stress is tested. Our threads withdraw more than 50 washing cycles. It's protected by Czech utility model. The main advantage of our solution is the potential to produce a lot of different types of hybrid conductive threads. So we are able to tailor specific threads according to customer needs or intended application. We can use different type of metallic materials. We are experienced with silver-plated copper, with brass, stainless steel, and also with bronze wires. Moreover, the number of individual microwires within the threads can be adapted, so we can achieve the different level of electrical resistance. On this slide, you can see the structure. There is the threads containing just one stainless steel wire, but these threads contains more than 4, I think that's 8 silver-plated copper wires. Next few slides, I will show you how our electrical conductive threads are compatible with textile manufacturing technologies. Woven in electronics can be represented by highly conductive textile elastic ribbons, where our threads, by means of weaving, create a variable amount of conductive lines or tracks. Also, we can achieve standardized electrical spacing 2.54 millimeters. The principal advantages are stable electrical resistance during stretching, high elasticity with no change of electrical resistance, high abrasion of the ribbons, and high resistance to maintenance stress. This product is protected by Czech patent. Knitting technology allows to create heating clothing parts, for example, heated lumbar parts of outerwear, or there you can see completely heated bed sheets with even temperature distribution. Or if we use the threads with different level of electrical conductivity, we can create integrated sensors like this. For example, sensors of presence, including motion detection, sensors of humidity. All these types of products show, again, high mechanical resistance and resistance in washing and drying process with no substantial effect on electrical conductivity.
1 minute.
Yeah. The threads work well also for sewing and embroidering. The representatives of embroidering electronics are capacitive buttons like there, and temperature sensors in upper side, in the right side. However, it's important to consider that the upper threads undergoes more threads during sewing. Therefore, we recommend to use softer or more ductile metallic materials like copper, silver for upper threads. And there you can, this slide summarizes potential fields of applications. The target groups include protective clothing, home care or hair care, sport and fitness applications, and conductive stretchable rigid ribbons, as already mentioned. However, textiles with conductive pathways or patterns are still not yet true smart products. The conductive paths need to be contacted to each other, connected to LED diodes, printed circuits, etc., and especially connected to power supply. Nowadays, soldering, bonding, or crimping of components are used for contacting, but we are looking for alternative, not so rigid solutions, allowing reliable and cost-effective interconnecting technology. The work is focused on technologies based on ultrasonic plastic welding, resistance spot welding, and thermocompression contacting. And in remaining time, which I haven't, what we are working on now and in the future. We are continuously working on improving of existing solution, taking into account quick technological development, especially new conducting materials, encapsulation possibilities, and power supply means. As I said, we do all the best to commercialize our results on the market and make our innovations useful and accessible to the customers. If you have already encountered the CleverTex trademark somewhere, be assured that this brand covers just our textile products. So briefly, thank you very much for your attention. And in case you would like to test our products, please contact our company or me personally on these contact mentioned on the last slide. Thank you very much once more.
Perfect. So first of all, thank you for the invitation. Today, I will try to share a little bit with you what CeNTI is doing in the field of e-textiles and how we are taking advantage of the advanced materials for this type of developments. Just to talk a little bit about CeNTI, what we are a Center for Technology and Innovation. Our focus is on research and technological development for companies, completely based on nanotechnology, advanced materials, and smart systems. And our main mission is really to support our different industrial partners in developing new products, new solutions with these disruptive functionalities. We are around 200 full-time R&D researchers divided in different departments. So this means that we have a very, very broad technological focus, and we work from material-based solutions like nanocapsules, nanoparticles, and nanostructure solutions that we can integrate in different types of materials and substrates, up to different areas of microfabrication and printed intelligence, which you will see some examples here in the field of e-textile-based solutions. But we have also competencies in embedded system automation and software, so we cover different areas within our technological development, and our main goal is always to develop the solution from a lab scale up to a pilot scale and industrial scale line. We, of course, are in line with the main thematic principles of bioeconomy, sustainability, performance, technological innovation, and also digital transformation of materials and processes. And we try within our solutions to always respect these main thematical principles. We have a multi-sectoral approach, so we don't only work on e-textiles. In fact, I would say that e-textiles are around 10 to 15% of our business here at CeNTI. But in fact, we develop e-textile-based solutions for different areas, as you can see here. CeNTI has a wide spectrum of applications. We work for automotive, construction, health, energy storage, and generation. And the beautiful part of e-textiles is that you can find solutions for all of this sector that I mentioned. So why are smart textiles important? I think this is the first question that we shall ask. In fact, textiles have been growing a lot. It is expected that within 2030, we'll have a growing of 30% within the market, driven mainly by wearable technologies. But in fact, we see that currently advances in textile manufacturing, these supported also by the development of functional and smart materials, are enabling new solutions and the generation of new e-textile-based products that are appearing in the market. CeNTI, located in the north part of Portugal, this is one of the strongest regions in terms of textile expertise in Europe. So we are also in line with this, and we are collaborating with our industrial textile partners to try to also include this type of solutions in their portfolio. Why are smart textiles so interesting and with such a very broad application? Basically, textiles are quite complex in the way that they combine. Through the combination of different materials with different structures, we can obtain completely different technical features. These, together with the combination of smart materials, like, for example, conductive yarns, conductive inks, enables new functions that bring out completely different functionalities from the textile structure. And this makes them suitable for different applications that can go from health, well-being, military and defense, up to high-performance composites. So there's a very, very broad spectrum of applications and solutions that can be generated through the combination of standard textiles with advanced material solutions. At CeNTI, we focus on two different approaches, which is one of them is fibers and yarn-based. So at CeNTI, we focus on the development of one hand, new fibers. So by melt spinning and for example, wet spinning, we focus on the development of new fibers that can include directly in the fiber-based structure new functionalities. So these enable us, for example, to fabricate fiber-based electronic devices, like for example, piezoelectric fibers, piezo-resistive ones. On the same page, we can also work with coated yarns. That is something that is widely seen in the market. For example, silver-coated polyamide yarns are used in many different e-textile-based solutions, and this is also a field where we collaborate. And finally, but not less important, in many cases, both of these commercially available solutions or the solutions that we develop indoors in terms of yarn lack the mechanical and functional properties to be integrated, for example, directly in a weaving or in a knitting process. So in many cases, for the fabrication of a fiber-based sensor, it's necessary the combination of functional yarns and use, for example, hybrid cords to fabricate completely disruptive solutions. So this is also an area where we collaborate and we try to develop different solutions. In this case, working mainly with conductive elements like copper, like silver, and also taking advantage of other type of high-performance fibers, like, for example, carbon fiber, to fabricate e-textile-based solutions. In alternative, we also work in print electronics. So print electronics is also an excellent approach, as you saw, for example, from the example of Sensingtex, to integrate directly sensors on flexible substrates like textiles. At CENTI, we have quite expertise on this type of developments. We can have different approaches. We can print directly on the textiles. We can print on interface layers and laminate them afterwards on the textile, or we can print directly on a polymeric substrate that has the same flexibility and properties of the textile-based solution and make a post-integration. And the fact that we can have similar functionalities in terms of the yarns that we can have on the inks, because we can also apply conductive inks, electroluminescent inks, thermochromic inks, we can obtain different functionalities for textiles. So at CENTI, we try to explore both approaches, so combine flexible electronics based on yarns with also print electronic solutions. This leads us to different levels of integration. So we can work, as I mentioned, directly on add-on solutions. So we can fabricate our devices in external, like a printed sensor on a polymeric substrate, and work on the lamination of it on the textile. This is a much more easier integration solution, less demanding, and what we see a lot currently in the market of e-textiles. We can also work on integration onto. So basically we print directly on the textile substrate and we have a solution completely embedded in the textile surface, or we can use standard and traditional textile processes like weaving or knitting to have a seamless integration. So what our yarn is directly in the structure of the textile solution. This brings further issues in terms of interconnections, but is a much more industrial scale process in terms of yarn integration. Or we can work on a hybrid approach, that is embroidery, where we integrate directly in the textile surface, but at the same time, we don't use any knitting or weaving processes. This is a process widely used on e-textile solutions and something that we also can see a lot in the market. All of these solutions have one issue, that is interconnection. Right now, this is the biggest challenge that we face on flexible electronics, and this also relates to e-textile-based solutions. That is, we have a flexible solution, but we have right now not a standard way to apply a connection to textiles and to e-textile based devices. So connecting a yarn or connecting a printed track is not the same thing. Different textile substrates make a huge impact on the flexibility and on the requirements of the solutions. There are different approaches, and CENTI has expertise, I would say, in all of them that we can use. But right now the path is a custom approach. So for each challenge, we have a specific connection method, which difficult then the next stage, that is upscaling of the solutions. Nonetheless, there are currently companies focused on this area, and from CENTI side, we also try to collaborate always with this type of solutions that is already partners involved in integration of electronics directly to standard processes, like, for example, embroidery, and also companies completely dedicated to customized bonding processes that will allow to make this bridge between the flexibility of textile and printed circuitries with standard hybrid electronics like hardware, LEDs, PCBs that are rigid, and making this bridge between these two solutions. What type of applications can we handle with the textiles? Many of them. So we can go from biomonitoring solutions like ECG, EMG, EEG, EOG. And this is something that is more dedicated to wearable devices. I have here an example of this solution integrated in roofs, but we have here a lack of time, so I'll leave then the presentation for you to see these examples. We can also work in textile-based solutions based on lighting, like optical fibers, OLEDs, LED wires, and make their integration directly on textile substrates. This is an example on carpets that we developed in the past. We can also work on thermal regulation through different approaches, directly to embroidered, printed systems, and also directly in weaved structures. This is another example. And finally, what I would like to highlight is what are the main challenges that we have here with the e-textile sector. That is, where are we going? So if we want to implement this in a completely industrial scale, there are four main topics that we must assess, in our opinion. That is, firstly, the scalability and reliability of our manufacturing processes. So we must be sure that the technologies that we use to fabricate our devices are in line with high throughput upscaling processes, a bigger synergy between textile manufacturing and electronic processes, because right now these are two different fields, but e-textiles are converging these two areas, and a big understanding must be assured. Also, work on market acceptance and consumer skepticism, because this is a really, really big topic. And finally, something that is already being a big topic is standards. So how we can really have standards for smart textiles, and how we can certify these solutions, which will also lead in the future to a bigger market acceptance and help to grow this market. So CeNTI is focused in all of these fields, and in case you want to have any question, any doubts, please don't hesitate to ask. Thank you.
Hi, everybody. Thank you for hosting us here at this event. It's an honor to share experience from our field. Thank you also for presenting me. That was nice. And I will jump into the presentation. I believe you can see it correctly, right?
Yes.
So this presentation, the main aim is to introduce you how we teach the world to the wearable technologies, or more specifically, light knit technologies. Sunfiber itself is a technological company that is in the textile market, but we are developing only the components of the wearable technologies, which is based on fiber optics, and is illuminating the fiber optics, so it's a visibility and safety factor. We are integrating, or not us directly, but our customers are integrating this into final textile products like jackets or backpacks, basically to anything where the visibility can be improved. Just briefly about our story, we are a very young company. Actually, our company was established in 2014, and since then there was very difficult and complex development. But we launched our products actually in 2021 under the brand Sunfiber, and that is how we are selling this technology nowadays. That is how we are presenting everything. And now I would like to tell you why. Why are we even proposing this enhanced visibility solution? Well, simply it's because today standards that are in use are not enough in some conditions. And when I say some, I mean actually quite a lot. So I think we all can agree that visibility is very crucial for safety. Yet current solutions that I told you fall short, especially in low visibility conditions like complete dark or rain or fog. So that's where these traditional methods that we call here on this slide, you can see as passive visibility, I would say rather, these are based more on some external source of light to reflect or to absorb light, like reflective tapes or high visibility colors. On the other hand, what we are proposing and what our technology is about is the active visibility, active lighting, which is basically using autonomous light. And on the picture is on the right, and there is on the picture in general, you can see the main difference. For example, that when you stand out from the light cone of the car, you are still visible. You are having your own light, and you're not dependable on external factors to be actually safe. So this is one of the main differences and reasons why we are doing this technology, and what it changes in the industry of safety and personal safety, personal visibility. Also, when you think about it, everything on the roads that is important and unique is marked by light. So you don't hit, for example, another car, or you don't hit something, some obstacles on the road, but not humans or people at the roads. And the main reason was simply because it was very hard to develop some professional and durable and washable solution for garments. And here we are proposing our solution, and for several years we are supplying this successfully. This slide is practically telling the differences between the passive one and active one. I already talked about it a bit, so I can skip that. You can look that later. What I would like to point out from this slide maybe is the connectivity on the right side, on the active technology part. The connectivity, it's a huge trend for super professional garments nowadays. I don't know, for example, you can imagine a very technical police ballistic vest or tech wear where you can find more active technologies like sensors, GPS, data collectors. Like I think even Kevin mentioned some sensors. So this all can be interconnected on the garment, and light can be incorporated as well. So this is a huge trend nowadays and very complex one. I would like to share with you some key factors that basically this slide is summing up the 4 years of experience that we have on this field, that the textile companies that are making the garments are looking for when they are adapting active technologies. So, technologies focused on lighting. First of all, scale of visibility, how much is visible and how long, for which distance. Then we have control options, if there are any, or is it too complicated, for example, for the user. Then they are looking for durability, because obviously nobody wants their jacket to be ruined by some new technology that they are implementing. So there is also a huge key player, the skepticism that also Kevin was talking about. The design, the product needs to be elegantly integrated. So you need some discrete solution that will be also very easily integrated in the factories that are not only, of course, in Europe, but also in China and everywhere on the world where the textile companies are manufacturing their products. Also, the price, that is a huge topic. Textile companies are used to play a very complicated and strict game of margins. So when you are introducing some technologies to them, they are not used for paying higher prices than for those components that they were already using. For example, the reflective tapes. So when you are comparing, for example, €2 reflective tapes and €18 lighting technology, it's very hard to convince the market. But it's possible, but it's hard. Then, of course, certificates. It's very important to have a very good solution that is certified and is complying with some standards, which, on the other hand, nowadays in Europe are slightly behind. But that should change sooner or later. So that is what we are looking forward to, for example. And sustainability, of course. In our case, we are achieving that mostly by making eco-designing our product to have less waste and doing everything according tailor-made to every project that we have, because it's a life-saving product mainly. All right, sorry. Yeah, these are the key characteristics that we have in some fiber for our technology. That is why we are the market leader and why we can sell to sectors, to complicated sectors like police or emergencies or workwear, and be successful. Like washability, for instance, that is a huge topic for all smart textiles and technologies. That is some product overview. You can see we have a lot of colors, we have a lot of connectors and power banks and fibers, but that is practically the product, which I will show you later in some other slide integrated already. We are also creating a strong brand. We are trying to be the leader not only from the textile, the technical point of view, but also from the brand point of view. And now I would like to show you some applications that we did. Normally in person, I would love to ask you what is your guess, which market is the best for us, for light technology in general. But here we don't have so much time, so I will tell you directly. It's law enforcement, so you can imagine police officers at the streets or at the highways, etc. So that is the biggest need coming from the market where we are supplying, but also, of course, workwear, sports or urban safety. It's also very interesting. So I've collected some pictures of the projects that we had, very few of them. So you can look that later. All are practically about safety and visibility. Some are also for signalization or identification of team members. You can also see that we have waterproof solutions for marine use or defense for military purposes. We have even infrared light, which is visible only under night goggles. So the scales of projects it's very huge, and safety plays a role in every aspect of every single sectors in these. So kids, even backpacks on the kids, etc. Urban safety, of course. So you can see that later. Then we have also some special projects we are supplying to our biggest customer, Thule or Linde Material Handling. And that is my last slide. I would like to share with you some challenges that we were facing while introducing this technology. We set up a very ambitious goal to revolutionize safety. At first, we were quite confident that we will be a rocket. It will be a rocket launcher. We will grow very fast. However, this was not the case, and we've encountered many problems, obstacles. And here's the list. Not the whole list, of course, but the main points that were slowing us down. Anyhow, that is that is the stuff when you are on the market alone and pushing some innovations as the leader. But we took this path, and it is much more than we are much more than happy that we did, because it's getting more and more successful and known among the textile industry. And that will be it. So thank you for your time. I hope you found this interesting. Since the time was limited, I will surely let you know my contact or something, so you can send emails. I'm sure you will share also my contact, or I will be here at the end. So thank you, and enjoy the rest of the seminar.
But I have a question to Miguel.
Okay.
For the concept that is, I think, is very interesting, and is very far that Sensingtex went in this domain and working in this area. My question is about that is, you are working only large areas, stretchable electronics. In any segment or any aspect to your, that is, you consider the biosensor aspects. What is the reality about biosensors in smart textile and stretchable biosensors in this context?
So do you hear me well?
Yes.
So thank you for the question. So we we have received quite a lot of inquiries and developed solutions for customers around biosensors. So a few of them even so we are supplying a few of them, especially basically for different biomarkers for heartbeat and respiration rate in a non-invasive way. But also there are other solutions like oxygen saturation sensors and all that. So, but we are very focused. The main in healthcare, the main let's say demand on that, at least from our side, is that they are looking for non-invasive. That was the topic of my talk. So non-invasive solutions at all. Something that we can either place a sheet on a bed sheet, okay, or we can or something that we can collect non-invasively. And this is our area of expertise right now. I don't know if I have replied your question, but
I was more like curious also from the presentation from Eva about the year, the high count. It can be oven knitted and all those things. So it's, I hope how far it is right now in terms of like wearable textile application. I see application in clothing, bedsheet, and home textiles, but wearable textiles like garment. Do you have any information?
Do you know our company is able to produce the high-count threads, and the final application will belong on companies which are devoted, which are engaged with final products manufacturing, and final products commercialization. Yeah. So we can only recommend or inform about our testing, about our results during the project, but we are not final supplier of smart textile as a whole product. We can also supply some partial solution for smart textiles creation.